I'm not sure what you guys heard. So essentially, what we're covering today is we're going to do a very brief dive into a type of digital design called discrete design. And essentially, in a nutshell, what that is looking at the way that very simple pieces, so in this case, we have one cross type component, one linear component. In this case, we have two different components, sort of an intersection component and a linear component. Here we have only two components, but how we can take those sorts of smaller components and build them up with very basic connection rules, or grammars if you want to use the very old school term, to sort of assemble this large construction. This sort of design, very hot right now. Sort of the, I'd say, contemporary originator of this kind of design is Kengo Kuma. Sort of influenced by a lot of very traditional Japanese connections, but aggregating these pieces over and over and over to end up with a kind of very interesting overall form. Some contemporary practitioners that are worth looking into are Gil Retsin. So again, sort of based his research on using small components to come up with larger constructions like this. You'll notice that one of the things we'll be working with is a blatant ripoff of what has become a very kind of recognizable style of linear wood elements with black ends. So I just thought it'd be fun to kind of replicate this in Grasshopper to show you how that's done. Some other contemporary practitioners are Jose Sanchez, who uses, I believe, the Unreal Engine to sort of create this, collaborative online discrete design thing. So it's worth looking into. Plethora Project, as well as Manuel Gemnes Garcia, who has some more sort of flowing geometries. So to that point, I will say that when we're talking about discrete design, even though the most well-known examples of this kind of design have kind of very rectilinear forms, it is worth noting that you can, if you're more someone who prefers, repetitive flowing forms, you can also work with that. So for instance, this chair here is made out of, I guess, these kind of weird goopy looking cylinders and spheres sort of joined together and filled and recombined into this sort of overall pattern. So in Grasshopper, kind of the easiest way to go about doing this kind of design is using a plugin called Wasp. Now, I understand that Food for Rhino was down last night, so if you look in today's class file, 200323 discrete geometry, you'll see Wasp 0208. So if you haven't installed it, I would very much encourage you to read over the installation note file in here. Just follow it very closely and install it while we're sort of going over the first few steps. I'm going to spend a bunch of time remaking some things in Rhino just to give you a better idea of how you can go about designing a component. So that'll give you a little bit of breathing room if you need to reinstall Wasp right now. One thing I will mention is for Rhino 6 users, you can just sort of ignore this Grasshopper Python installation note, because Rhino 6 has Grasshopper Python installed by default. So you just follow this. So I also have a Rhino file in today's class folder, so we're all going to start with that. So just go ahead and open this class file. So in this class file, when you open it, you'll see I kind of have a few things saved here. So first of all, I have these three kind of very interesting looking aggregations of pieces. We're going to be focusing on these two pieces here. So we're going to be doing something that, is a very, in this case, messy tower, but you can see how you can start to combine parts to come up with things like stairs and platforms and, you know, some very kind of interesting version of structure, as well as maybe a larger scale piece. Now, there's no scale to this. You could imagine that this is either, you know, 6 inches tall, or this is 3 feet tall. So if you are going to use this kind of design language for your assignment 3, it's worth thinking about scale, because you might want something that's made out of less pieces, but comes up with this overall interesting formal language. The third example here corresponds to the wasp example file layers, and the reason why I include this is just that if you look in the wasp folder, there's a lot of example files, and if you are interested in using wasp for your assignment 3 or just pursuing it further in your own time, I would highly encourage you to move throughout all these example files and sort of see what wasp is capable of doing. I think this is a very good way to learn it, so please do that. If you know, maybe go into advanced and sort of use some topo fields, you know, maybe that's the way you do your assignment 3. So essentially, in a nutshell, the way wasp works is you take 2 very simple pieces. So in this case, I'm just going to turn off the revised geometry 01 layer here. You take 2 very simple pieces. So in this case, 1 linear piece, 1 connector piece, like so. And you tell the computer, connect this linear piece to itself. Here, just going to zoom in here. Connect this linear piece to itself based on predefined rules. So the way wasp works is that it uses curves in center points to create connections. So for instance, one connection we could define is connect this point to this point, and then make sure that these lines are oriented in the same direction. So one connection that would happen is that if we define that rule and said we wanted 3 pieces in that aggregation, what would happen is we would have 1, 2, 3. So we define a very simple rule like that, right? But then we could start to define other rules. We could say, okay, connect this point in this line to this point in this line. And now what would happen if we tried to make that connection is that some other translations might start happening. So for example, this point right here would connect to this point, gonna go copy. This point would connect to this point right here. But along with this, there is also, we need to rotate this. Wasp will automatically rotate faces so that they line up. So essentially what's going to happen here now is we can assume that we're going to get a rotation like this. And also, since you can see this curve is in this direction and this curve is in this direction, we would also get a rotation 180. So that is what aligning this point in this line with this point in this line would do. And essentially, likewise, you define some other connections. You might say that this center point in this line aligns with this center point in this line. So you could imagine that a connection would be made like, you know, something like this. But then this would connect to something like this, and so on and so forth, until you get a big aggregation that looks like this. So this is essentially what we're going to do. We're going to aggregate using small parts to make a big thing like this. Now what I'm going to do, and if you're following along, you can just double click on the revised geometry there, and you can just delete the wasp example files. So what we're going to do is I'm just going to take you through the steps of designing a single component. So one of these pieces right here. And then from there, we're going to start defining rules kind of one at a time. So we're going to start with this linear component here. And then we're going to define rules one at a time. We're going to aggregate it linearly. And then we're going to start adding more and more rules until we end up with these very complex shapes. So again, these are one of those things it's sort of easier to explain by doing. So we'll sort of jump right in. You can open Grasshopper now. There's no Grasshopper file for this course. I'm going to open one just to refer to my notes. So you can see there's actually not a lot of grasshoppering, essentially, that we're going to do in this, although this is the wrong file. So. So another thing here too is I have a bunch of layers on. We're going to be recreating this. Maybe I'll do something slightly different for this class. So let's just start from the beginning. So essentially, if we're going to start to aggregate pieces, so for example, we're going to aggregate pieces like this into something like this. You first want to start about how you're going to define those pieces and what kind of piece you want to aggregate. So why don't we go ahead and make a new layer. So I'm right clicking my layers and I'll just call this class example. And I'm going to make a new layer just so I can move this stuff out of the way so we can kind of refer to it. But you can use this geometry instead of what I'm doing here so you don't fall behind. But I'm going to go ahead and make something new. So I'm just going to move these components over to the side, like so, and we'll refer to it. So what I'm going to do is I'm going to set up a very, very, very basic component in a very, very basic set of rules, and then I'm going to start adding some complexity to it to show how you can start thinking about these things and how you can start building them up. So there's a few things we need. To define these rules, we essentially need connection directions and connection center points, as well as the piece of geometry itself. So I'm going to make 3 layers under this class example. So I'm going to right click the class example layer I've made. I'm going to go new sublayer. I'll call this one geometry. I'll right click class example and make a new sublayer, and I will call it direction. And I will right click the class example again, new sublayer, and go center point. For the direction, I'll click on the color here and I'll change it to a green just so we can differentiate quickly between what layer we're on. And the center point, I'll click on the little color icon there and set it to be red. Now, what I'm going to do to begin with is before I start to make a more complex shape like this, I'm going to start off by making a very easy shape to just sort of show you how wasp works. So what I'm going to do is I'm just going to start by making a block. So I'm just clicking the box corner to corner. You can also type box. And I'm just going to make a simple box like this. So this is going to be the first piece that we aggregate. Now, the other thing that that wasp needs to work is it needs a center point and it needs a direction. So why don't we click on our direction layer, and we're going to draw a line. We're going to draw it from the center of this face up to an edge. So I'm going to click on polyline. And there's a few ways you can snap. You can try clicking on center. So in your object snap, click center. See if you can snap to center. I can't. So then you could also try turning on mid, making sure that smart track is on. And then if you turn on mid and smart track, you can sort of find the intersection of all those points like so. If you're having a hard time snapping that way, you could also always just draw from mid to mid, and then you could go transform, scale 1D, and scale that line to this center, like so. But essentially, we just want something that looks like this. Now, what we want to do is we want to set our current layer to be our center point. And now what we're going to do is we're going to click on single point. You could also just type point, and we're going to put it in the center point of this face, or the start of our directional curve right there. Now, the way wasp works, the way its grammar is set up, is that we need to tell it, okay, connect this point to somewhere else, connect this line, make sure this line is oriented with another line somewhere. So to begin with, why don't we just try starting connecting these blocks end to end? So what I'm going to do is I'm going to select my line and my point. So I'm just left clicking and dragging over both the line and the point. And I'm going to go transform copy, or you could just type copy. And I'm just going to copy it from one face to the other by selecting the corners there. So essentially what I'm doing is I have center point, directional line, and on this face, center point, directional line. So that's all we're going to do in Rhino for now. So we're just going to set up a system where we can array these things in a straight line. So let's jump into Grasshopper and start to define some rules in Wasp. So we're going to go ahead and we're going to build up the entire definition in Wasp to get to work. And then, like I said, we'll add complexity as we go along. So click on Wasp. You should have it if you followed the installation instructions properly. And essentially, Wasp is organized in a way that's kind of nice. So essentially, it leads you through the steps. So you have 1 elements, 2 parts, 3 rules, 4 aggregation. So essentially, we can just follow through these steps and kind of find the things we need. So the first thing we need to do is define our elements. So what we can do is we can go wasp connection from directions. So elements, wasp connection from direction. So create a connection or a given part geometry from center and x-axis direction. So that's essentially what we've defined here. So center and the axis direction. So the first input is geo. So geometry. So we are going to define this. So we'll go to params, geometry, brep. We'll set our brep. So we'll select our box here. I'll right click the brep and go set 1 brep. I'll plug that in. Now, the origin of the connection plane, we're going to set 2 points. So we're going to set 1 and we're going to set 2. So we need to now select the center point. So what we can do is we can go to params, geometry, point. And we can right click this point and go set multiple points. So I'll select the one on the left, the one on the right, and I'll click enter. Now, what I'm going to do is I'm just going to right click this point component and call it center points, just, for reference later on. And I will plug these center points into this center connection input. So now the final thing we need to put in here is the directions of the axes, so the thing that allows WASP to orient its different connections. So we need to define a few curves. So these green lines here, so we can go to params, geometry, and then curve. I'll right click this curve component and just call it up direction. And then we'll go set multiple curves. So I went left to right, click enter, and I will put that in the up direction. You can see what wasp does is it just generates two planes. So it gives a an x direction, an x direction. So you can imagine if you were to connect this plane to this plane, essentially what's going to happen is we're just going to create something that looks like that. So that's our first very basic aggregation rule. So I'll delete those. So now we have two connections coming out. So the next thing we need to do is we need to define our part. So essentially what we can do here is if you just look at wasp, so we've defined our element, and then we can go to two parts. So what we can do is we can go to wasp basic part. So two parts wasp basic part. And this right here, it has a few inputs. So this is essentially going to define like not only this geometry here, but a wasp part is the geometry as well as its different connections. So that's what we're defining here. So the first thing we want to do is define a name for this part. And this will come in handy later when we sort of need to filter out our different parts to bake them. So why don't we just call this part block? So to do that, let's go to params, input, panel. I'll double click on the panel and I'll type block. I'll plug that into name. The second part is, the second input is our geometry. Now, if we read what this says here, so part geometry, it'll be converted to mesh to improve performance, perform the conversion before adding the part. So essentially what that means is that wasp always works with meshes. Meshes are a lighter geometry than NURBS geometry. They're harder to edit. But you can imagine that if you were going to try to make this thing in Rhino with NURBS geometry, your file might get very heavy very fast. So what we're going to do is we're going to convert this brep to a mesh before we aggregate it in WASP. And that's just going to make things a lot easier on our computer. So what we can do is we can go to mesh, utilities, mesh brep. So again, that's mesh, utilities, mesh brep. Hover over it, so create a mesh that approximates brep geometry. The brep input will just take our box brep component right here, plug into the brep input. And then the geometry will take our mesh and plug into geometry. Our connection is going to be our connections list. And we have two connections here. But what I'm going to do, because in the future we'll want to add more connections, is I'm just going to start to sort of plan ahead. And I'm going to use the merge component in anticipation of wanting to add more connections. So what we're going to do is we're going to go to sets, tree, merge. So sets tree merge. This connection, so the connection direction, the connection output's going to go into data 1. And what this is going to do is it's just going to right now merge our current list of connections with nothing because we haven't defined anything else. But in the future, when we set up more connections, what we're going to do is we're just going to copy our other connections into data 2. If we have more connections, we'll copy into data 3. So this is just a nice component to kind of keep our connections organized. So we'll take our merge and we'll plug it into connections. Now, the collision, essentially what this is happening is WASP will attempt to prevent geometry from overlapping, which is nice. So it means that a box will never do something like, you know, that, for instance, where we have overlapping geometry. If your shape's very complex, you might want to provide an optional collider geometry. So In other words, if your box was like a mesh that was like a highly complicated mechanical part, maybe you just want a bounding box as your collider geometry instead. Since we're going to be working with fairly simple geometry this class, we can just leave this as default. And then finally, the part attributes. If you are working with a huge system and you want to define some other piece of information in almost a BIM-like manner, you can put some extra part attributes in there. Maybe it's used for labeling, for instance, if you're actually going to CNC or laser cut these objects. So at this point, I think it'd be good to start to maybe label some parts of this definition. So right now we have our connections, we have our parts. So maybe we won't group, but what we will do is we'll just make sure that our parts are a little bit separate than our connections. Maybe what we can do is go to params, input panel. And sometimes what I like doing is just using a panel as kind of a divider. You could also draw a line as a divider. I like using a panel. And then sometimes I'll even right click on the panel, go to color, and then set its color to something very dark. And then that way it is essentially just a divider like so. Maybe what we will do as well is under params utilities scribble. So that's params utilities scribble. I'll just sort of label what these different areas are. So the first one will be connections. So again, that's param utility scribble. The second one will be parts. So now that we've defined our connections, so these ends, we've defined our parts, so essentially that's the geometry and its connections. The next thing we need to do is define some rules. So define some rules to say connect this end to this end. So let's go to wasp, rules, and then we're going to go to wasp rules generator. So wasp rules generator. Now, hover over it, automated rules generator given a list of parts. And essentially has two different operations. If there's no rules provided, then it's just going to make all the connections possible. If rules are provided, it's going to define some different rules. So why don't we start by the first input here is part. So parts from which to generate aggregation rules. Let's plug in our first part. Just referring to my notes. So now at this point, essentially what we can do is you can see it's generated 4 rules. From this point, we can actually just aggregate. So why don't we essentially copy this divider again, like this. I'm going to copy this scribble. I'll just call this rule generator. So we have our connection, we have our parts, our rule generator. Right now, we'll go back into sort of more clearly defining some rules, but right now, what you need to know is happening is it's just looking for all connections it can make between these two ends. So that's fine. So now what we need to do is do aggregation. So what we'll do is we'll go to wasp aggregation, and then we're going to go to wasp stochastic aggregation. So essentially what stochastic aggregation is it's just going to randomly choose connections. So it's going to say, okay, I have a given amount of connections I can make. I'm going to randomly choose one, and I'm just going to aggregate as much as possible. You can use a reset switch to restart that aggregation, so we'll look into that. So again, choose wasp, aggregation, wasp, stochastic aggregation. So what we're going to do is we're just going to look at the inputs. So the first one is parts to be aggregated. Right now, we only have one part, but let's anticipate that we're going to have future parts. So what we're going to do is, again, we're going to get a merge data component. So I'm just going to move this, kind of divider over a little bit, just to make some room for a merge down here. So what I'm going to do is I'm going to go to sets, tree, and then merge tree. And I'm going to take my part output, and I'm going to plug into data merge. So again, in the future, when we have more parts, we'll plug another part into data 2. But for right now, we're just taking this part output and plugging into data 1. It's merging my one part here with nothing here. It's flattening that list, so I only get one part coming out. So we're going to take this result of the merge and plug into the part input of the stochastic aggregation. Previous, this is an optional thing. It's if you want to build off of a previous aggregation. For now, we'll just leave that blank. N is the number of parts to be aggregated. So you can imagine that right now there's one part. If we're aggregating based on the one rule we've set up, if there's 4 parts, essentially that'd mean 1, 2, 3, 4. So very simple like that. So what we're going to do is we're going to create a slider for that. I'm going to double click on the canvas. I'm going to say minimum 1 part. I'll say less than 500. Hit enter. And I'll plug this slider into N. And one thing you will sort of notice pretty quickly is that it seems like you might think, whoa, 500 parts, that's a lot. When you are aggregating this kind of stuff, you know, I'm not sure how many parts are in here, but it's a lot more than 500. So if you are working through this kind of design methodology, you will use sometimes thousands of parts. So start at 1, but make sure your maximum number is quite large. So now we have this block. We can define our rules, and our rules will come from our rule generator. So just take your rule generator output and plug into rules. Mode, we can leave default. So we will eventually deal with some global constraints, but right now we'll leave it blank. Global constraints, again, we will deal with this. Essentially what this means is you want to make sure that your parts are aggregated within an overall form. So you want to give a boundary condition. We'll deal with that a little bit later. After that, aggregation ID, we won't worry about that. If you're doing multiple aggregations, maybe you want to instill that data into your aggregation. For now, we won't worry about it. The last thing we need is reset. In this, we're going to use a Boolean switch. So similar in wasp or in Kangaroo, when we reset the physics simulation, in wasp, you can reset the aggregation with the reset button. So let's go to params input button. Put that on the canvas and then plug this button into reset. So you can see that nothing happens even when we move this slider. Now, the reason why is that a wasp aggregation type is not the geometry, it's literally its own kind of data type. So now that we have this aggregation, essentially what we need to do is we need to break it down into its components. One of those components is the geometry. So what we're going to do is we are going to go to wasp. We're going to go to referring to my notes. We're going to go to wasp, and then we are going to go to, where is the name filter? Oh, we're going to go to wasp parts, wasp filter parts by name. So wasp parts, wasp filter parts by name. And essentially what this is going to do is it's going to take our parts and it's going to filter it by name. Yes, that is what we need to do. So the parts out, essentially what we're going to do is we're going to take the part out from stochastic aggregation. We're going to plug it into the part in our name filter. And then the name, we go back to our parts component, and we're going to take the panel where we've defined our block name. We're going to plug that into the name input of our name filter. And what this is going to do is it's just going to allow us to break up our parts by different types. And then finally, the last thing we're going to do is we're going to go to wasp parts and then wasp get part geometry. So that will extract the geometry of the part. So wasp parts get part geometry. The part out will plug into the part, and now you can see we get our aggregation. So you can see when I'm re-clicking, essentially what's happening is that these ends are getting the end lengths are changed, and that's because the array of parts on this side is slightly shifting. They're changing on this side, but we're not getting a lot of difference because we've really only defined two connections, right? We've really only defined this one block, and we've said you can only connect on your sides like this, right? So that's why we're getting this very kind of boring connection. So what we want to do now is we want to define some more connections in order to start to build up this system into something interesting. So what I'm going to do is I'm just going to close Grasshopper for a moment. I'm going to zoom in on my basic block part. So view, zoom, select it all. And then I'm going to start thinking about different ways I could connect this block together. So for instance, I could select this direction, this center point, and I could always just, we can always just honestly in this example copy a bit randomly to say, okay, we want our parts to connect right there, and maybe we also want to connect right there, and also we want it to connect right there. So let's just sort of put some more connections on your block like so. Let's open Grasshopper again. And let's go back to our connections. So what I'm going to do now is I'm going to preview off my geometry out just so we don't get that overlay of excess geometry. And our brep, it's this. We don't want to change that. We're still referencing the same object. What we want to change is our center points and our up direction. So first, let's set our center points. So I'm going to click on my center points input. I'm going to right click it and go set multiple points. And then I'm going to select my points around my object. And I'm going to hit enter. So this component's going to turn red because we haven't selected the proper corresponding direction lines. But what I'm going to do, because sometimes when you're building up a component in WASP, you're going to select a ton of different points. Essentially what I'm going to do is I'm going to label the order of points that I've selected, so it makes it a little bit easier for me to select the corresponding up directions. So what I'll do is I'll go to display, vector, point list. So display, vector, point list. And my center points, I'll plug them into the point input. And these numbers look a bit small to me, so maybe I'll right click on the size input. So S input, change the size to maybe, let's try 3 is kind of small. I'll say 10. Whatever size works for you. And this essentially is just showing me the order in which I selected these points. And this is useful now because I can right click on the up direction. I can go to set multiple curves, and I can select these in the proper order. So you have to select your curves in the same order as you selected your points. So 0, 1, 2, 3, 4, hit enter. And now all of my sides are connected. So now if we think about what's going on here, this block, it can connect, since we're automatically generating the rules, we can connect this line to this line. So ultimately that means the block's going to do something like this, right? It's going to copy there, and then it's going to rotate. Oop. It's going to, roughly speaking, rotate like that, and then it's going to make this connection there. This future block, it'll retain all these connections, so maybe there's another block now that makes a connection like that. And then there's another block that makes a connection like that, right? So since we've defined all these connection sides, we're kind of allowing it to aggregate in a random way. So let's see the results of that. So if we go through to our definition, we can preview on parts geo now. We can set reset to the aggregation, and you can see our blocks are aggregating in a random way. And if we increase this aggregation, you can see they are aggregating like so. So this is, I'd say, the kind of the start of our first interesting aggregation, as it were. Does anyone in the chat have any questions about this so far? Is there anything you want me to re-show again? Is anyone else getting a similar aggregation? Is anyone following along and getting this? Okay, well, anyways, the video is there. But ultimately, when you work to this step, you should get something kind of interesting like this. What we can do now is we can start to define some custom syntax. So what that means is that we're going to define the rules. So right now, because the rule generator, if we highlight over our rule generator component, on the output, you can see it's generating 25 rules. So it's taking however many sides we have here, 1, 2, 3, 4, 5, and it's combining each of these 5 connections with all other 5 connections, meaning 25 rules. What I'm going to do is I'm going to preview off the part geometry, and I'm going to start defining these connections as something different from another sort of connection. So right now our parts are aggregating in the horizontal, right? So they're creating a horizontal plane. We might want to start aggregating them in a third dimension, so moving them up and down. And we might want to differentiate between those two sorts of connections. So that's what we're going to do now. I'm going to preview off geometry, and I'm going to go back to my connections list. Now, this T input for the connections direction, now we're going to add in a name to the connection type. So I'm going to go to params, input panel. I'll double click on the panel, and I'll call it horizontal. I'll plug the horizontal panel into T. So essentially this is saying these rules, this set of connections I'm making, are called horizontal connections. So you can see here the output wasp connection ID 0, type horizontal. So we've defined the connection type. We can now start to make a vertical connection. So what we can do is we can copy, Control C, Control V, all of this connection stuff. You know what I might do actually? I might just remake this as kind of a review. So why don't we review that? So I just deleted that. I'm going to go to WASP. I'm going to go to Elements. And then, so WASP, Elements, Connection from Direction. So same component we have here. The geometry is still going to be the brep. So same brep here. But I'm going to set new points. So what I'm going to do this time is I'm going to set some center points and directions on the top and bottom faces. So maybe I'll close Grasshopper. I'll set direction is my as my current layer, and I will just draw a line across the top like so. So I've just drawn a line straight across. I'll type in scale 1D, and I'll scale that to the midpoint like that. So I've just defined this direction like that. I'll set my current layer to center point. I'll click the point button, and I'll put a point in the middle of this face / at the beginning of this line there. I'll take this line and this point, and I'll go transform copy, and I'll copy it from this line, or from this face to this face down here. So these are going to be my I'll call them vertical connections, so we can start stacking this geometry in 3 dimensions. I'll open up Grasshopper again. So I'll open up Grasshopper, and I have this second connection direction here. And then I'm going to start defining my center points and my directions. So let's first start by defining our center points. So I'll go params, geometry, point. Again, I'll right-click this point and call it center points. I'll right-click center points, go set multiple points. I'll go from the top down. So top one, bottom one. What I might do is I might copy this points list component, or just a review to as where it is. I'll go display, vector, point list. I'll plug my points into the P input of points list so I can see 0, 1, the order I selected the points. And then now I can go to params, geometry, curve. I'll right click the curve, go set multiple curves. I'll follow the order of the points, so 0 and then 1. I'll right click this curve, call it up direction. And the up direction I will put into up right there. The points I will plug into center points. And then finally, I'm going to want to label this connection. So I'll go to params, input panel, and I will label this connection vertical. And I'll plug that into T. So now I have 2 sorts of connections. I have the horizontal connections and the vertical connections. Now what I'm going to do is I'm going to take this connection output, and we have this merge data component feeding into our WASP basic part component here, right? In the anticipation of further connections. So what I'm going to do is I'm going to take this connection direction component, I'm going to plug into D2. So now we're merging together 2 of these connection direction components, the horizontal and the vertical. So now essentially what this is doing is it's telling WASP that this part block, this geometry here, has the 2 different connection types, vertical and horizontal. So we have this part coming out. That's good to go. Now let's go to our rule generator here. So by default, if we preview on our geometry, hit reset, what you're going to see happens is now we're starting to array in 3 directions, right? We're starting to array both in 2D and also in 3D. And what's happening is that our rectangle is starting to, tilt 90 degrees in the vertical direction. So it's starting to rotate here. It's starting to rotate like this way instead of just in that XY plane. So, and the reason why that's happening is because we haven't defined any specific rules. Essentially, we've just told wasp to array any way you want, do whatever you can, and you see when I hit reset, it's just sort of giving us these random agglomerations of parts, which looks kind of cool, but maybe we want a bit more control over it. So this is how we can edit wasp syntax to sort of define what connections can and cannot be made. So if you look at the optional GRs list, essentially these are going to be the optional grammars. So the way we can define these, I'll just move over my aggregation component, is we can just take a panel and type in rules. So we can go to params, input panel. I'm going to right click this panel and set it to be multi-line data. So again, that's right click, multi-line data. And the reason why I do that is because we want to enter in more than one entry. I'll double click on this panel. And what I'm going to do is I'm going to refer back to my rules, and we're going to use a syntax like this. We're going to say horizontal greater than horizontal. So horizontal to horizontal, and then I'll click out of that panel. So this is our first rule. This is the syntax that wasp takes. So it's connection name greater than connection name. Now when we plug this into GR and hit reset, it just goes back to having horizontal connections, right? Because we've said that the one type of connection you can make is horizontal to horizontal. Now, if you remember, if we disconnect this, you can see that again, we get these connections made where the block right here, look at this vertical block, it's rotated 90 degrees to connect a vertical connection to a horizontal. Maybe we don't want that. Maybe we just want these blocks to stack on their sort of top to bottom. So if we wanted to define that relationship, what we could do is we could just, in our grammars list, we want horizontal to horizontal. I'll hit enter to start a new line. And now maybe what I'm going to do instead is go vertical greater than vertical. So vertical to vertical, I'll click outside, hit reset. And now you'll see what happens is we don't get those rotations anymore. We're just getting stackings. So essentially what I mean is if I maybe just stretch this out a little bit so it's easier to see. Now we're just getting stackings of objects, so you don't get any rotated pieces. If we want those rotated pieces, let's preview this off. So right now, by connecting vertical to vertical, essentially what we're saying is you can go like this, right? But you can't connect this end to this end here. If we want to make that 90-degree rotation and allow these blocks to rotate a lot more freely, essentially what we can do is we can double click into this list and we can go horizontal to vertical. And this is something that you'll find that you might want to do, is sometimes you need to make the connection both way. And what I mean is you have to type horizontal to vertical, but you also want to type vertical to horizontal. Click outside this, hit reset, and now you can see it's making those horizontal to vertical connections. So it's arraying quite freely in all 3 dimensions. So what I'm going to do now is I've created these few different parts here. And what I've done is I've sort of just built these off a different block. And I've, effectively tried to, convincingly rip off some of the geometry you see in projects like this, right? So they're usually made of rectilinear members, a lot of times rotate 45 degrees, and they kind of have these male-female connection points to allow for solid connection. So essentially I've just taken the time to model that kind of stuff. Actually, we might have time to remodel it, so maybe I'll do that. So why don't we take this block here and sort of add some more complexity, and I'll show you how I did that. So we have our one block here. If we want to make this more of an interlocking member, essentially we can do this quite easily. So what I might want to do is I have this block here. I'm going to go transform copy. I'm just going to copy it like so. I'm going to take my end connection that I defined right there, and I'm going to define, or I'm going to move those end connections off of the block. And also, if you're not following along with this, or you're trying to, but you kind of fall behind, I will resave this in Dropbox, so don't worry if you fall behind a bit. I just want to show you how I go about thinking about designing a piece like this. For your assignment 3, actually, I feel that a lot of your effort should be spent designing the individual component. So anyways, we have our block piece. I've copied it over. What I'm going to do is I'm just going to scale 1D, and I'm just going to make a connection point here. So what I'm going to do is I've created this smaller block on the end of the longer block, and now I'm just going to scale this 1D. I'm going to, before clicking this point, I'm going to type 0.5 to scale it half. I'm going to click here. I'm going to type 0.5 to scale it half. Like so. So this is essentially going to be one part of the connection. So we want a receiving portion of this connection. So what I'll do is I'll take this little block here. I'll go transform copy. And now what I'll do is, because I might want to show a little bit of a reveal, it's kind of nice to see, to be honest. What I'm going to do is I might explode this object right here, deselect the sides, select the 4 sides like so, click join, and now I'm going to go to surface, offset surface, make sure I'm going out like that. I'll set the distance to, let's say, 1, and that's going to give me something like this. And essentially what I'm doing is I'm just creating a reveal so that when I join these pieces together, I see that little shadow line, which will look very nice. I'll select this object, I'll go solid, cap planar holes, and then now what I'm going to do is I'm going to Boolean difference this shape here. So select that shape, select Boolean difference, and I will Boolean difference like that. I will take this piece right here, select the bigger piece, I'll click Boolean union, and then finally I'll go solid, solid edit, tools, faces, merge all faces. So this gives me my standard kind of block. So it's just a little bit more complex than that block we had before. And really that's all I'm working with here. But you can see that that gives us like a much nicer looking piece, a more believable looking component. Now what I'm going to do is I'm going to take my defined center lines and I will move them just to the center of these faces I've made right here. Now you always want these lines to go halfway through a face, so what I'm going to do here is I'm going to select this line in the center point. I'm going to go scale 1D, and I'm going to scale it to the midpoint of that face, and I'm going to do the same for the other side. So I'm going to scale 1D and scale to the midpoint of that face. So now you can see that what that's going to do is it's going to make a connection between this point and this point. So essentially it's going to make this connection. Like so. And you can see there's that nice little reveal I was talking about. You don't have to put that, but I think it looks nice. So that's the connection we're defining there. Now, you might also want to make this connection, right? You might want to connect these pieces so that this piece can rotate like that, right? And in order to make this direction, or this connection, essentially what you need to do is you need to just take this curve and this point. So select both the curve and the point. Move it out like so. And you just want to rotate it 180 degrees and go transform move, so that you're defining that rotation ability. So that's what that's doing right there. Essentially, you're allowing this piece to either orient to this direction or rotate 180 to orient to this direction. You also want to do the same on this end. So I'll just drag that out while holding Alt to make a copy. I'll rotate it 180 with the gumball, and I'll go transform move and move it to the center point like that. While I'm here, maybe I also want to sort of clean up my my side stacking. So right now what I've done is I have all these kind of random lines and points on the sides of my geometry. Maybe I just want to select all of those, delete them, in order to better define where I actually want to stack these pieces together. So what I like doing when I'm thinking about systems like this is I actually just like copying the piece like that and thinking about how it's going to stack. So for instance, let's say I want to make this connection like so. This connection is very simple to make, right? All I need to do is set my direction line to be my current layer, find the midpoint of this surface, scale 1D, just so our direction is only halfway through the surface. Set my current layer to be the center point, draw a point at the end of that line / the center of the surface, and then I can copy these over. So transform copy. So we want to make this connection here. So the bottom connects to the top. And that's going to give us this sort of connection. Now, let's say besides that connection, we also want to make this connection. So we'll go transform copy. That connection right there. To make this connection, it's going to be very similar to this connection. We can just set our current layer to direction. We can draw a line right through the center of the face. Select this line, go scale 1D, scale it to the halfway mark, set our current layer to be the center point, and then copy this over. So transform copy. So now that what that's going to do is it's going to allow us to move in that direction there. Furthermore, I'll just make one more connection here because, you know, we're already, I think we're starting to get the hang of this. Let's say you want to make a connection like this, so you want to shift over your system. Essentially what you can do, what I like doing is I like copying my object over, figuring out the kind of connection I want to make. So right there, I shifted it over. And then I just like finding a pre-existing connection point on my original geometry. So I'm selecting this original point and line here. I'm holding Alt to drag it over. So let's select the point as well. Transform copy. I'm just taking this point and line and I'm just going to move it over, transform move to right there. So that's making the connection. And then I'll select this line and point, and then I'll just move it from a point on my translated geometry. So I'll select this upper left-hand point here, and I'll move it to the same point on my original geometry. And that's going to create that translation point. So we've created a little bit more complex geometry. What I'll do now, before I reference it, is I will save it in the Dropbox, just if you want to grab this new file. You can also work with the geometry in the revised geometry 1 layer if you want to follow along with something a little bit more complex. So anyways, let's go back into Grasshopper. And now let's define a new brep. So I'll select this brep here. In my brep setting, I'll right-click brep, go set one brep. And then I'm going to change my labeling for my connections, because this geometry is a little bit different. What I'm going to do is I'm going to say that these connections here and here, this mechanical lock, or this mechanical joint that we have there, I'm going to call it ends. So I'll call my first connection type ends. And then any connection made on the sides of this component, I'll just call sides. Click OK. If I go back to my rule generator, these rules don't make sense anymore because we don't have any of these rules. So I might as well just delete that panel. And now let's start saying some more points. So for my end connections, what I'm going to do, and this one's a little bit different because we have 2 overlapping points here, is I'm going to select my points on the end, and I'm going to move 1 over to the side. And why I'm doing this is so we can easily select them. So you do have 2 points on each of these end faces. I'm just moving 1 over to the side. I'll do it for the other end. And this will just allow us to select them better with Grasshopper, and then I'll move them over again. So let's right click on our center points input, go set multiple points, select 1, 2, 3, 4, hit enter. So 0, 1, 2, 3 on that side. Let's go select multiple up directions. So I'll right click this, go set multiple curves, 1, 2, 3, 4, hit enter. You can see that it's automatically updating. That's actually the previous, so you can see now all the connections I'm getting by default are kind of these rotating pieces here. What I want to do is I want to take this center point that I'd shifted over for selection, move it back to the actual center. Make sure your point snap is on. So that shifts there. Find the other point we've shifted over. This shifts there. We can reset our array. So now you can see we're just creating this long linear array like so. We can set our center points now in, and our up directions for our sides. So why don't we do that? So we can go to right-click center points, set multiple points. 1, 2, 3. Now I'm just clicking these in whatever order because we have that little point label. We'll be able to refer to it after. I've select all, I'll hit enter. So, and then I'll right-click the up directions and select these in the same order. So right-click up direction, go set multiple curves. 0, 1, 2, 3, 4, hit enter. These are sides, and now when I hit reset, you can see that our geometry is now arraying in that manner. If I want a little bit more control over the way these parts are distributing, I can now add in a few rules. So I have my side or my ends in my sides. I can go to my rule generator. I can add a new panel. I can double click on the panel. Actually, before I double click on it, I can right click it. I can go to multi-line data. Then I can define a connection end to end. So end greater than end, and sides greater than sides. Plug that into the grammar input. And now you can see what's happening is we're getting this kind of really interesting array of kind of these clusters like so. Now, one thing to mention is once you've set these up, if you do want to, let's say, rotate them, you can do that. So I just rotate in 45 degrees, and now I get the rotation 45 degrees like so. Now, essentially, let's start to add in another part. So we've sort of, does anyone have any questions about how to kind of aggregate array a single part? Sort of set up some basic rules in WASP. Okay, so then what we can do now is I can talk about how you can make another part. So the way that I might do this is I might just start to take this as my base geometry, and I might just make a sort of connector piece that can connect these and make these turn angles. So maybe what I'll do is I'll take this piece like that. All I did was I held Alt and dragged it over with the gumball to get another piece. You could also go copy paste. And I'm gonna maybe create a corner part for this. So what I'm gonna do is I'm just gonna delete all of the side connections, and I'm only gonna create something that connects to the end pieces. So what I'll do is I'll take this geometry and I'm going to just grab the midpoint. You can grab wherever on this piece. I'm drawing a line across it. And I'm dragging out the line like that. There's lots of ways of doing this. You could draw a box, you can draw a line. I just went polyline and drew a line essentially across my object. And what I'm going to do is I'm going to go to Surface, Extrude Curve Straight. And I'm going to extrude a curve through this object. Again, you could draw a box and do Boolean difference, but I'm just going to go split and split with that surface. And then I'm going to go transform, rotate 3D. Rotate 3D, I'm just saying an axis, so the axis is this hinge point here. And essentially, I'm going to select one reference point. I'm going to hold Shift to make sure I'm locking to 90 degrees. And I'm just going to create this angle piece here. And I will I'll select both of these split pieces, and I'll go Solid, Cap Planar Holes. When I'm doing this rotation, I'm also making sure to rotate these end connection points because they've already been set up, so we might as well use them, right? Now, maybe I want to add a different kind of connection to this. So you can imagine that if we introduce this piece into the system, all of a sudden we're able to start, you know, translating around corners and whatever. Maybe we want to make this a little bit more flexible. So maybe I will also select both of these pieces, all their connections. I'll hold Alt, drag it out, and maybe I'll just decide to rotate it like this. So I'm just kind of randomly rotating it. I have these two pieces now. I'll transform move to sort of move them into place. And essentially I'm just making a corner piece like this. You can see that maybe I need to shift over some geometry to make this, you know, align properly. Maybe I need to trim away some geometry. You sort of need to do whatever you need to do to make this geometry look nice. So in this case, I'm going to shift this over slightly. Maybe this piece is centered on the midpoint like that. And this point here is centered on the midpoint like that. Let's go to right there. And maybe this piece is also, I'm trying to center its midpoint to a midpoint right there. Like that. And then this gets shifted over. So essentially what I'm doing here is I'm just trying to make this piece look somewhat nice. If you're actually using this method for your assignment 3, you're going to want to sort of take care to actually design these pieces a little bit better so they actually, you know, fit together in a meaningful way. For right now, I'm going to say this is good enough. Essentially, I've just created a connection piece and I've maintained the connection center points and directions. What I'll do with this geometry now is I'll just select all these brep components. I'll hit Boolean Union. And from here, I'll save in the Dropbox. So if you want to follow along with this one, you can. So I'll just go Save As and Discrete Geometry 02. Okay. So now we're going to add in another part in WASP. So we've already added in one part and sort of aggregated that one part. Now we're going to add in another. So let's open up Grasshopper and let's add in a new part. I'm just going to preview off this array right there. So to add a new part, we need to go back to the beginning and we need to start out by defining connections. So let's go to WASP parts, or sorry, WASP elements, WASP connection from direction. So that's WASP elements, WASP connection from direction. The first input is geometry, which in this case will be our new sort of angle connector. So let's go to params, geometry, brep. I'm going to right click brep, go set one brep. I'll select that brep there. I'll plug that into geo. The center points is going to be all the center points of the object. And again, since we have double points here, before we select all these points, what we want to do is just select one of the 2 points on each of these connection sides and just shift it over slightly. So that's going to allow us to easily select them in Grasshopper. Otherwise, if you don't do this, what you'll find is that sometimes you might not select a point, and then it'll cause WASP to throw an error. So we're just avoiding that in advance by slightly moving over those points. And we'll move them back again, of course. So we'll go to params, geometry point. We can right click this and call it center of points. We'll right click it and go set multiple points, and we'll just select these points in whatever order. It doesn't really matter because we'll use the point list to visualize the order we've selected after. To use the point list component, we go to display, vector, and then point list. We'll take our center points, plug them into point list. That'll just show us the order. So 0, 1, 2, 3, 4, 5, 6, 7. And now we can select our directions in the same order. So we can go to params, geometry, curve. I'll right click the curve component, call it up direction. I'll right click this and go set multiple curves. And I'll just select in the same order as the points. Hit enter, and I'll plug that into up. the center points, I'll plug into center. And finally, I'll move these center points back to the center of their faces. So transform move. Transform move. Transform move. And transform move. So there we have our center points centered on these pieces. The final thing we want to do is list the connection type. So since we're starting to build up some complex aggregations, we want to keep things organized. So we've called these ends, we've called these side connections, and maybe we want to call these angles. You can call it whatever you want. So we'll go to params, input panel. I'll double click and call this angles. I'll plug that into T. So now we have our connections. So what we're going to do now is we essentially are going to create a new part. So this part here, it is the part, the block, which contains all the different connections a block has. So let's create a new part, which we'll call an intersection maybe. So to make a part, we are going to go to wasp. We're going to go to parts, and then we're going to go to wasp basic part. So we need a name for our part. So I'll go to params, input panel. I'll double click the panel. I'll call it intersection. I'll click OK. I'll plug that name into the name. The geometry will be our B-rep we referenced here, but remember we want to convert it to a mesh first. So what we're going to do is we're going to go to mesh, utilities, mesh B-rep. We'll put that on the canvas. We're going to plug our reference B-rep, so the one when you select it, it's this intersection object turns green. I'll take this B-rep, I'll plug into the mesh input here. The mesh output will plug in into geometry. In the connections here, we're going to take the connections and plug them in. Now, just as a matter of habit, because we might again want to add more connections for this piece here, we're going to use the merge list component is sort of a placeholder in anticipation of more connections being defined. So we'll go to sets, tree, merge. Put it on the canvas there. We'll take our right now one connection, plug into merge D1. So it's merging our first set of connections with nothing. So it's just giving us our first set of connections. And we'll plug that into connections. So collider geometry we'll leave as default. And part attributes we'll leave as default. We don't need to do that right now. So now we have this other part. And what we can do, since we have the merge right here, that's going into the parts list, we can just plug this part, our intersection, into the merge list there. And now, if we click the button, essentially it's going to give us an error because we haven't defined everything we need to. But the other thing too is if we zoom this down, it's not going to give us an error to a certain extent, because essentially what it's doing is it's saying if you keep pressing reset, eventually it will randomly aggregate it, so it's just aggregating mostly linear pieces like that, so it doesn't give us an error there. What's going to happen is it will start to give us an error when it reaches an aggregation where it hasn't had any rules defined for this piece here. So in order to define some rules for this, we need to essentially add some things into our grammar. So the grammar, since we've defined the angles is the new connection, we can say angles to ends and see what happens there. So in your rules grammar input, so this list of grammars, you can type angles greater than end. Oh, and the reason why it's still having an error is instead of plugging my parts merge into the rules generator, I only had my first part plugged into the rules generator. So make sure your merge parts is plugged into the rule generator as well. Let me refer to my notes here. So the other thing I think that's not working here is that we have our angles to end, but I think we also might need end to angles. So again, sometimes you need both. There we go. Now we're starting to see stuff, I think. Now, if this isn't working, like it's not for me, what we can do is we can disconnect our grammars list so that it finds all the grammars. And what this is telling us here is that it is working. It's just we need to sort of troubleshoot. So we'll do that. So the other thing you'll notice here is that not all the parts are showing up. And that's because we need to copy this name filter and then the part geo list, and then all the parts will show up. So what I mean by that is we'll go to wasp, we will go to parts, and then wasp filter parts by name. So that's wasp, parts, wasp filter parts by name. The parts out will go into part. In the name, we will connect our intersection to the name. So now that's going to give us our parts out. And then to get our geometry, we're going to go to wasp, parts, and then wasp get part geometry. So this part out will go into the part input of geometry. So now you can see that we have our aggregation of the two different pieces. Now let's plug our grammars back in and try to kind of figure out what's going on that makes it mess up. So I think what's going on here is that you can see that it really likes going side to sides. If we take out sides to sides, click OK, it's really not giving us much. If we go angles to end, end to angles, again, it's not giving us much. So it's kind of interesting here. There's something going on with this. Let's disconnect this grammar and see what happens. So it's kind of an interesting problem because there's something wrong with our grammar that is preventing this connection from happening. It might be the thing that let's just try rewriting our grammars here. Let's go over it again. So to write grammars, go to params, input panel. We're going to right click the multi-line data. The first grammar let's just define end to angle. So we'll go end less than angles. We'll plug that into grammar. See what the error is. No rules provided. So that is very strange. Is anyone else trying this and it's working? Because I'm not actually sure why it would do that. angles to end. Okay, so I'm going to try changing my name to angle singular. It might be that there's actually maybe a space there. It might also be that I just forgot to make a connection here. Merge, part. Let me refer to my notes. That's actually very strange. Not sure why that's not working. If we... Yeah, so... I'm going to have to be honest, try to troubleshoot that, because as far as I know, this really should work, and I had it working last night. Here, let me just see what's going on here. Rules, part. You know, I wonder if it's something as dumb as, let's try using all caps for these rules. So my rules I'm renaming to end, side, angle, block, intersection. So let's try going angle, angle. Oh, you're kidding me. So the one thing I noticed from my previous rules is I had them in all caps. So it looks like you need to have all caps. Yeah, that's it. So when you're defining your rules, make sure they're always in all caps. Will, does that work for you? Can anyone confirm that that's solving the issue there? Okay, that is strange. So one of the things about Grasshopper that's so wonderful, but it's also sometimes kind of frustrating, is it's an open source program where people develop their own components, so it allows for tons of different plugins. Sometimes those things have bugs or don't act how they should. So essentially make sure that the rules are all caps. Learn something new every day. So now when we're defining our rules, I'm going end to angle, angle to end to end, and then side to side. And now we're starting to get this kind of interesting aggregation like so. Maybe I want to take out end to end and just see how that looks. So this is how you would use two parts in WASP. So essentially you can figure out two different parts. Now, there's two other things I want to show you before we go. So the first thing I want to show you is how to create a boundary shape. And last night I found it was a little bit glitchy, so hopefully it's a little bit less glitchy today. But again, this is open source stuff. It's still interesting to use, but know that there are limitations with it. So for a bounding box, what I'm going to do is I'm simply in Rhino going to go solid, extrude planar curve straight, I could have clicked box, but essentially I'm just going to make 2 boxes like this. You can choose whatever shapes you want. In theory, it should work. The one thing you want to make sure is they both fully enclose your original shapes like this. And I'm just going to click Boolean Union to join these 2 boxes into a shape like this. I can go to View Wireframe, and this is essentially going to give me a view of my parts within a box. So you want something like this. Now, if you look at the stochastic aggregation component, there's global constraints to apply aggregation. Essentially what this means is that we can define something that these parts need to be in. So to do that, you create your boundary shape. So this could be the outline of your tower. You could go to params geometry brep. I'm going to select my brep. I'm going to right click it and go set one brep. I'll right click this component and I will change its name perhaps to boundary object. And I'm going to convert it into a mesh because Weaverbird works with meshes. So I'm going to go mesh, utilities, and then mesh brep. So I'll plug this boundary object into the mesh brep. Under wasp, I believe it is, yeah, so wasp aggregation, wasp mesh constraint. We're going to select that. And essentially this is just going to create a global constraint. So the first input is geo. So it says plain to use as constraints. That's a typo. Again, open source. We're going to plug our mesh into that geo input. The second input is a Boolean. So false to allow only parts outside the constraint, true to allow parts only inside. So true by default. We'll leave it as true, but maybe we'll grab a little toggle switch. So we'll go params input Boolean toggle. I'll plug that into the input, set it to be true because we want these objects to array within this object. And then the final input is soft. And essentially this is true to check only the center point, so the centroid of the geometry. Whether or not that is inside your boundary shape. False is going to make sure that your object does not intersect with the bounding geometry whatsoever. In past experience, this function doesn't always work exactly how it says it does. By default, it says it's set to true by default, so it means true to only check the center point. We're going to leave it as true by default. Essentially what that means is it's more or less going to stay within this boundary shape. Once you've defined this, you can take your GC, plug into the GC input in your stochastic aggregation. It's not going to do anything right now because what we have to do is we have to go to mode and we have to set our aggregation mode to global constraints. So you can see there's a list here: 0 equals no constraints, 1 equals local constraints, 2 equals global constraints, 3 equals both. So what I'm going to do is I'm going to right-click mode. I'm going to go to set data item. I'll move this over here. Set data item, and I'll set it to be 2. So that, according to this legend, 2 equals global constraint, so that should work. So we hit reset, and now you can see that our geometry is only aggregating more or less roughly within this bounding box. If I make it a little bit smaller, you'll see how it will kind of follow into this secondary box here. So let's see. So yeah, if I preview off this mesh, you can see that it's starting to create stuff in there. Now if I increase the number of pieces, let's say I increase it to 2000, click OK. So my computer is taking a moment to think. It's going to try its darndest to only aggregate these pieces within that bounding shape. So there we go. So now we're starting to kind of build up an interesting way. You can see it's actually fitting this shape quite nicely. So that's starting to give us some really interesting looking geometry. In fact, you might want to bake these parts. So we haven't baked anything yet, so maybe let's bake them now. So I'll bake these. Oh. So I'll right click this component, click bake. I'll just save on the class example layer I made. I'm grouping it. I'm going to right click the angle points here, bake. Again on the class example, group, yes. I'm going to click OK. I'll go to view, switch to rendered mode, and you can see this is starting to look like kind of a cool thing. Which kind of leads me to this point here. So how I made something like this where I'm starting to define floors and stairs. Ultimately, the short answer is you can't make this in Grasshopper. Totally. What I did was I took something like this, where I'm starting to maybe see, oh, there could be a floor here, there could be a floor here. And what I did is I just started to edit this thing, kind of chip away, add in, add things. So for instance, I selected maybe one component here, and I went transform copy, made sure my vertex select was on, and I just kind of copied this over, right? So now let's double this up, copy. And I just started to say, okay, this is my floor module. So I kind of faked it. And I mean, honestly, this is good enough. So I said, this is my floor module. Like so. Maybe I copy this one more time in this direction. So there's my floor module there, and I say, okay, when I look at this, this looks like it actually might be a very nice place to put a stairwell. So then I delete these things until I have enough room for someone to walk through. And using the same kind of pieces, I just stack them to create a stairwell. So maybe here's the entrance to your piece, and we can delete some stuff like this to create a set of convincing stairs. Maybe you have to model in a stair after, maybe you stack these same self-repeating pieces to create stairs. It doesn't really matter. Ultimately, you need stairs, and you can still use this kind of discrete aggregation as the basis for your stairs, but you know, you modeled them in there. Likewise, you actually need a platform. You can't just submit this and say, yeah, people climb all over this. Instead, what I'd like to see you do is kind of selectively take maybe a floor piece like this. I'll just group this. Move it more accurately so it actually fits within your overall system. So in other words, transform move, make sure you're snapping vertices to vertices. And then, you know, start moving this around, copying and pasting it. And then maybe start deleting some stuff like, you know, I'll ungroup that, you know, maybe say that's not needed. So there we go. There's our viewing platform, but we also have this cool sculptural component. Maybe also you want to add some structure, so you take some more vertical pieces and you start to say, okay, in order for this to look, have more realism, maybe I want to, again, do this in a more controlled way. I want to start making some columns that link up these floors. So in other words, use this aggregation as the base if you really like this method, but then afterwards go through, add floors, and you can see I added stairs. So that's how I did that. So if you're going to do this method for assignment 3, you're going to have to do some post-processing, but really it doesn't take very long, and you end up with kind of a cool looking aesthetic that you probably wouldn't be able to get otherwise. The final thing I want to talk about is how you can, so these are all one object, right? Or they're all on one layer. I want to show you how you can sort of easily define a wood texture and let's say an end texture. So to do that, it's essentially you're going to be replacing pieces. So what I mean by that is I'll just delete this here. Oh, I'm going to undo my bake. Actually, I'll just select these. I'll delete it. I don't want to delete my original geometry, of course, which I just did. I'm just going to undo until I undo my bake. Okay. I'll hide that. So now I have my shape right here. So I'll turn off grasshopper, and I have, I think, yeah, so I have my two pieces hidden. So if we look at these pieces I'd already modeled yesterday, you can see that I have another layer here called fancy geometry. And essentially what fancy geometry means is I'd just broken this piece into wood siding and kind of this colored end to get that real Gilles-Retsin aesthetic, right? And then also I had, you know, broken up this surface in a couple ways to get some more visual interest here. So I'll show you how you can do that. Essentially what you're going to do, if you do that, is wasp allows you to transform very simple geometry like this, and at the end step, replace it with more complex geometry. So when you do that, essentially what you can do is you can iterate through aggregations pretty quickly, but then at the end you replace it with something a little bit more complex. So for instance, I can go to my class example layer here. I'll right click it, go new sublayer. I will call this detailed geometry. And under my detailed geometry layer, I'll create two layers. So I'll go new sublayer, I'll call it wood. Right click this again, new sublayer, I'll call it color. So again, I'm going for that same general aesthetic. Feel free to do whatever you want. This aesthetic is just out there, so I'm doing it. And then I'm going to select the piece that I want to replace with, you know, more detailed geometry. I'm going to hold Alt, gumball, drag it out. And essentially what I'm going to do is I'm going to start breaking this up in a few different ways. So the first thing I can do is I can select this geometry. I'll hit explode. And I'll set some of these side pieces to a wood layer. So I'll right click the wood layer and go change object layer. I'll change the wood layer's color just to make sure I can see what is being changed and what isn't. So you can see what I'm doing right here is that I'm saying all these pieces here be wood. And I'll go view, zoom, select it all. I can select the wood layer, select objects, I'll hit join. And then I'll just preview off wood layer. I'll select these ends, I'll hit join, I'll right click color, and I'll go change object layer. I'll change the layer of this colored object just to, again, differentiate what is going on, just so I can visualize what's happening here. Now, if I want to add more visual interest to these surfaces, kind of in the language of this style, maybe what I want to do is I'm just going to maybe fake another kind of joint in here. So what I can do is I can, you know, draw a line around here. And I'm just going to do this very simply. I'm going to go solid, extrude planar curve, straight. Maybe you want to make this an actual joint. Maybe this is a new kind of piece. For this, I'm just faking it to kind of, I don't know, add more visual interest. So I'm drawing this just simple thing here. And go transform copy. I'm going to scale this. And then I'm going to go scale 1D. And this is my, you know, connecting piece. I'm not totally sure how this works, but this is just something to make it look more interesting. Apparently in movies and science fiction, it's called greebling. You add random stuff to take it from a simple looking object to something that's very complicated and complex and neat looking. So I'll select my wood surfaces, I'll click split, I'll select the B-rep that I just made, I'll deselect the parts I want to keep. I have kind of this cruciform shape here, and I will change this extrusion to the color layer, and then I'll just go Boolean union to sort of create a solid shape. So this is my more complex version of this shape here. Again, it doesn't matter what you really have, but this is the more complex shape. So what I'm going to do is I'm going to go into Grasshopper again. I already have this array here. I'm just going to preview it off. And essentially what I'm going to do is I am going to go to wasp, and then parts, and then wasp deconstruct part. So wasp parts, wasp deconstruct part. The part out of my aggregation, I'm going to put into the part in of deconstruct parts. Again, it's giving me the geometry, but the other thing it's giving me that's really interesting is the transform. So we've used a generic transformation before, and we're going to use it again. So essentially what this transformation command is it's not telling you about the geometry itself. It's saying, here are all the steps this little piece of geometry took, like a couple rotations, a couple shifts, a couple scales, maybe even in some cases, to get to, let's say, this piece over here. And you can take those transformation vectors and rotations and instructions essentially and apply them to a different piece of geometry. So what we'll do is we'll take the transformations, and we're going to use the mask that comes out of our name filter to separate between the transformations applied to our linear piece and our kind of angle piece here. So if you remember, to differentiate between those two parts, we use the name filter. Now it also gives us a mask. So what we can do is we can take this mask, we can go to sets, list, dispatch. The list we want to dispatch into two lists, A and B, will be our transformation. The pattern will be the pattern based on one of our name filters. Now this first name filter here is based on the block. The block is this linear element here. So the mask will be true whenever it's this piece, false whenever it's the angle piece. And what that means when we plug into the P input of dispatch is A is going to be all the blocks transformations, B is going to be all of the angle piece transformations. So now we have all these generic transformations. What we can do is we can just simply transform these detailed pieces. So I'm going to preview off this deconstruct parts, and I'm going to reference the pieces here. So first what I'll do is I'll reference my wood pieces here. I'll go to params, geometry, brep. I'll right click this and call it wood pieces. And then I'll go set multiple breps. And then I'll go to geometry brep. I'll right click this. I'll call it color pieces. And I will select all my color pieces there. So right click color pieces, go set multiple breps. Now what I'm going to do is I want to turn these into meshes. So again, my computer doesn't die. So what I'll do is I'll go to mesh, utilities, mesh brep. So mesh, utilities, mesh brep. Plug the wood pieces into one mesh brep. Again, mesh, utilities, mesh brep. Put the color pieces into the other mesh brep. And then I'm going to join these pieces together. So remember, meshes, you can create what's called a disjoint mesh. So these can be considered as one mesh, even though they're technically physically not connected with each other. So to do that, we'll go mesh, utilities, mesh join. We'll need two of those. So mesh, utilities, mesh join. We'll plug our first meshes into mesh join. We get one mesh output, which is the wood. Plug the other mesh into the second mesh join. The output is all these colored pieces. And then we'll go to transform, utilities, and then we'll go to transform. And we'll need one for the wood pieces, one for the color pieces. So Control C, Control V. The geometry that we want to transform is the wood pieces. The geometry we want to transform is the color pieces. The translation vectors will both be A. So you can see those detailed pieces have been transformed in the same way. And then the translation values A are plugged into the second transformations for the end pieces. And now you can see the end pieces have been transformed as well. So we can bake those onto different layers. So we'll make a new layer called translated detail maybe. A new sublayer called wood. New sublayer called color. And we'll bake these onto those layers. So the second transform, you can see it's the color pieces. So I can right click that, go bake, select the color layer, group, yes please. Transform, I'll select our linear pieces, the wood pieces, right click that, go bake, select the wood layer, group, yes please. I'll go back to my my angle pieces, which, you know, you could also make these detailed. I haven't yet, but I'll select these. Right click that layer, go bake. I'll bake you onto the wood layer, group, yes please. I'll exit grasshopper. I'll go into Rhino. And what I'll do is for my translate detail, the color layer, I'll click the little circle here. Or what I'll do is I'll click the material selection here. So material, the little circle here, I'll click that. I have a few materials already set up in this file, so you can make your own material. We've already covered that, but I'll select black, click OK. Let's go to view rendered. So now you can see I have this interesting black detail that has been populated across all these parts. And then the wood, I can simply select the default material for the wood layer and switch that to wood. And now you can see that's how you can go about creating that kind of look quite quickly. So I'm going to leave it at that. I know we kind of ran through a lot. I kind of want to cover as much stuff as possible. But this is kind of the basics of aggregation. So like I said, if you're going to use this kind of methodology for your assignment 3, you'll have to do some after the fact cleanup to take this from a cool looking sculptural mass into an actual architecture. But I would highly encourage at least a few of you to sort of do this method. I think it looks pretty cool. Does anyone have any questions before I take off? Okay, so it looks like we're all good then. So thank you all very much. I'll stop this. I'll upload this video later today. And if you have any questions for me, feel free to email. Okay, hope you're all enjoying your quarantine. Bye.